Welcome to our deep dive into the fascinating world of the periodic table. It's not just a chart on a classroom wall, no way. It's a roadmap, a calendar, a tell-all book about all the ingredients that make up our universe. Today we'll explore its history, structure, and the properties of its elements. We'll uncover how this amazing tool helps us understand why things are the way they are and what makes each element unique. Get ready to unlock the secrets of the periodic table. Back in the 1860s, a brilliant Russian chemist named Dmitry Mendeleev had a light bulb moment. He was trying to organize the 63 known elements at the time, and guess what? He noticed that when he arranged them by their atomic weight, elements with similar properties magically appeared at regular intervals. It was like a pattern was emerging. Mendeleev was so confident in his discovery that he even left gaps in his table for elements that hadn't been found yet. And guess what? He was right. He predicted the properties of these missing elements with incredible accuracy. Can you imagine the look on everyone's faces when these elements like gallium and germanium were actually discovered? Fast forward a few decades, and along came Henry Moseley, a sharp physicist who decided to dig a little deeper. He discovered that each element has a unique atomic number, which represents the number of protons in its nucleus. This was a game changer. Moseley rearranged the periodic table based on atomic number instead of atomic weight, and boom! Some discrepancies that existed in Mendeleev's table vanished. This arrangement, my friends, is the basis of the periodic table we use today. So, what does the modern periodic table look like? Picture a grid with rows called periods and columns called groups. Elements are arranged in increasing atomic number just like Moseley figured out. But here's the cool part. Elements in the same group or column share similar chemical properties. This is because they have the same number of valence electrons, those outermost electrons that determine how an atom interacts with others. It's like a giant family reunion where you can predict an element's personality based on who it's sitting with. Chapter 4. Let's talk about those periods, those rows across the periodic table. There are 7 of them, and each period represents a different energy level that electrons can occupy. As we move down the periodic table, each new period means electrons are added to a higher energy level, farther away from the nucleus. Imagine electrons as students, and each period is a different grade level in school. The higher the grade, the more energy these electron students have. Chapter 5. Now, for the fun part, the 18 groups, or columns, of the periodic table. Elements in the same group share similar chemical properties. It's like they're part of the same family. For example, the alkali metals in group 1 are all super reactive, while the noble gases in group 18 are very stable and don't like to react with much. Why? It all comes down to those valence electrons. Elements in the same group have the same number of valence electrons, which dictates their bonding behavior. Chapter 6. To date, we know of 118 elements, each with its own story to tell. Some elements, like gold and silver, have been known for centuries, while others, like those at the bottom of the table, are synthetic and were only discovered recently. The discovery of new elements is a testament to human ingenuity, and the quest continues. Who knows what incredible properties these new elements might possess? One of the amazing things about the periodic table is that it gives us clues about the physical state of elements at room temperature. Most elements are solids. Think of metals like iron or copper. But we also have a few liquids like mercury and bromine. And then there are the gases like oxygen and nitrogen, essential for life. The periodic table helps us predict these states based on an element's properties and where it sits on the chart. You can also divide the periodic table into 4 blocks: S, P, D, and F. These blocks represent the different orbitals where those outermost valence electrons are hanging out. The S block elements are on the left side, the P block on the right, the D block in the middle, and the F block is way down at the bottom like a footnote to this amazing chart. Each block has its own personality, with elements sharing similar properties. The S block elements are highly reactive metals, while the P block contains a diverse mix of metals, nonmetals, and metalloids. The D block houses those shiny transition metals, And the F block is home to the lanthanides and actinides, many of which are radioactive. The periodic table helps us predict these trends and properties, making it an indispensable tool for chemists and scientists everywhere. Now, for the final piece of the puzzle, electron configuration. This refers to the arrangement of electrons within an atom's different energy levels and sublevels. Each element has a unique electron configuration, and you know what? It determines the element's position on the periodic table. The periodic table is like a giant apartment building, and the electron configuration tells us exactly where each electron lives. Thanks for joining us on this journey through the periodic table. I hope you've gained a newfound appreciation for this amazing tool that unlocks the secrets of the elements. Remember, the periodic table is more than just a chart on a wall. It's a testament to the power of human curiosity and the elegance of scientific discovery. Don't forget to like, subscribe, and hit the bell icon for more educational content. Stay curious and keep exploring the wonders of science.